In the last module, we have learned signals as functions of one or more independent variables. Signals are usually obtained naturally. For example, voice is obtained naturally as a speak. However, signals can be expressed mathematically or can be synthesized using some simulation softwares. Let's take an example of a signal. Example: say s equals to t square. Is it a function? Is it a signal? Yes, it is a function. Function of independent variable here, it is t. What function does it do? It simply squares the value, whatever the value that it comes in t. So the function that it provides is squaring. Let's take some values of t. Say for example, 1 will get squared to 1. Say for example, 2 gets squared to 4. Say for example, -2 gets squared to again 4. Say for example, 5 gets squared to 25, and so on. So we have a set of values that are getting mapped to another set of values. The set of values from which it is getting mapped, as we have seen, it is called as a domain. So here t is domain, whereas the values to which the values in the domain are mapped is called as range. So S here indicates range. So a set of values in the domain gets mapped to another set of values, and those set of values are called as range. Let's make a formal definition of function now. Definition: as we have learned, a function assigns a value, exactly one value, to each element in the domain. Let me explain this. You may see that a function, what is a function here? T square, the squaring function assigns a single value or exactly one value to each element in the domain. So 1 gets assigned to 1, 2 gets assigned to 4, -2 gets assigned to 4, 5 gets assigned to 25, and so on. So each of the values in the domain gets mapped to only one value. So 1 gets mapped to only one value, 2 gets mapped to only one value. You may observe that multiple values in the domain may get mapped to single value in the range. But an element in domain cannot get mapped to multiple values in the range. So that is not allowed. That means multiple values getting mapped to single value is allowed. However, single values getting mapped to multiple values, it's not allowed. If it does, it is not a function. Let's take an example. Example. Say S square equals to T. Unlike previous example, I have expressed this equation indirectly. So we can simplify this as S equals to plus or minus root T. If we try to plot graph of this equation, it will look something like this. On the horizontal axis, there is a time, whereas on the vertical, we have S, and we are taking the square root both in positive and negative direction. And so on. We may see that here a value in the domain T is getting mapped to two values. This is not allowed. We have seen that in the previous slide. On the previous slide, we have seen that a function has to assign only one value, assigns a value, exactly one value to each element in the domain. However, that is not the case in this example, the second example. Here, as we see a value here, say for example, value 4, if T is 4, it gets assigned to plus 2 and minus 2. This is not allowed. Therefore, this equation is not a function. Not a function, or it's not a signal. Why it is not a function? Because here one value is getting mapped to multiple values. So there is an ambiguity here. This is not allowed. Let's take some more examples. Example. Let's see x square plus y square equals to 1. Now we know from basic maths that this equation indicates the equation of a circle with center at 0 and of radius 1. So let's try to plot this equation. So if we try to plot this, it is a circle that is centered at 0 and with radius 1. So assume this is a circle. Now, is this equation a signal? Is this equation a function? No, this equation is not a function. Why? As we may see that if we look at some value, let's say here, a value is getting mapped to multiple values here as well as here. You can see that here for one value there are multiple values. Therefore, this equation is not a function. If you have any kind of confusion in whether an equation is a function or not, you simply make a test of vertical line. Try to draw a vertical line as I have drawn in this example and see whether that vertical line cuts at multiple points or not. If it does, it is not a function. A function allows cutting of this vertical line only once. Therefore, this equation is not a signal. It is simply a plot. It is simply a graph. Let's take a few more examples. Now I leave these examples for practice. Let's take example 4. Let's say x square plus 3y equals to 4. Is this equation a function? I'll give you an answer and leave you to analyze that this is not a function. I'll give some more examples. Example y equals to 1 by x square. This equation, is it a function? Yes, it is a function. I leave up to you to verify this. Another example. Let's say 2y plus 3x equals to 4. Is this equation a function? Yes, it is a function. Let's stop here. Thank you.